So in this video, we're going to cover data types and variables because they go hand in hand. Essentially, a data type is kind of like the type of something. For example, if you had a pair of socks and you put your feet inside of it, your feet are the data type of the socks. So socks would take the data type feet. Obviously, you could put other stuff in there like rocks and sand, but generally they're designed so that they put feet inside of them. Now, in programming, we have what are called primitive data types. It's generally these: the integer, char, double, and boolean. And then we have what's known as an immutable data type, which is a string. Essentially, the difference between these primitives and the immutable is primitives can be used in mathematical calculations. You know, you can add, multiply, divide, things like that, whereas a string simply can't. It has a special set of rules that apply to it. For example, if we added like this variable plus another string variable, it would simply just add it to the end of this line of text. The whole line is known as the variable declaration. We have essentially the data type. Generally, you have the scope, but when you're working within a class, you normally omit the data type or the scope type. Then you have the data type of the type of value or the type of data that can go inside the variable. You have some name that you give it. And essentially, this is just a name so that in memory, the computer knows where to retrieve that specific container of values. We have an assignment operator, which essentially says take the stuff on the right and put it in the stuff on the left. This is just a placeholder, this name. Essentially what it's doing is taking this value and storing it in the memory location where this matches. And then we have a semicolon which ends it. And these are the basic, these five are what you're going to be dealing with, probably the most common for programming. So you want to get comfortable with them. You want to get comfortable dealing with them. Comfortable with the idea of naming. And now this gets into when you're naming a variable, you want it to describe the purpose for the thing that it's being used for. Now these are very they don't really describe anything. They do describe the data type that goes in them. So in that way, I guess they're good. But they don't really describe anything else other than it's a variable and it's a data type. One key thing to point out is all variables, the convention is the first character is lowercase. And the same thing with methods. The first character is lowercase. The reason for this is it helps distinguish between a method and an actual class file. We won't get into too much of the convention or the reasons behind it right now. Just know that that's something you have to do. If I was a programmer, which I am, and come in and look at your code, and I see a bunch of variables with capital letters in front of them, I'm going to be confused right off the bat thinking, well, is this a class file or is this a variable? Because it has some class file equals this value, which generally doesn't work. I know a variable that can work with, but not in a class file. So that's just some things to keep in mind. And now how do we add values to variables? I mean, this is a very kind of a basic video. Obviously, most people kind of get the idea. You have a variable, which is a container. And I like to think of it in terms of essentially just a box. Some box, and it has a name. And it has some value in it. And the value obviously gets stored inside it. Let's say it's 5. So this variable, some variable might look like in Java code. So here's the actual variable someplace in memory, and here's the actual line of code, which is defining the variable of type data, or of type int, the name, which refers to where in memory it's at, and the value, which is inside of it. And those are kind of the components of a variable. So it's really simple to add something to a variable. You just simply use the equal sign and then give it some number and end it with a semicolon. Make that static, just in case we're going to be using these. And so now, if we wanted to see this, we wanted to print the contents of that variable to the console, we'd see just the value. And we could even go a step further. const of the variable this equals that. And then if we wanted to change this, let's say down here, and we just change it back to 5, and we run this again, it still says that, and it did change it. The problem is we didn't have another print line below that where that line of code is to show that the change took place. Now this brings up an interesting idea in programming, which is the code is executed line by line. So if you want something to take place before something, it has to go above it. If you want it to take place after it, it goes after it. I'm not sure what else there is really needed to be said about variables. Well, I guess there's one other idea. So let's say we have this variable here, which we know has 5 inside of it, and we want to turn it, let's say we want to store it in this double variable. For whatever reason, and then we want to display the contents of what's in there. So we run it, we get 5.0. Now, up here it just says 5. So how did it get a 0.0? Well, essentially because it's a type double, it automatically adds a decimal number to the end of it. And because we didn't do anything else extra here, we just see that transition take place. So if we wanted to take a double value and have it equal, or rather take an integer variable value and have it equal a double value, we have to do what's called casting, and this is essentially where you're converting a specific type to another type. Essentially, it's just parentheses and then the data type that you're trying to convert to. So notice now there's no errors, and now we're able to do it. Now in some editors it's not going to show you this, but in Eclipse it will. And then we want to see the contents of this. Now here's something that you may not know that takes place, but it actually, when you convert from a double to an int, it has this effect. So we run it, and it says the value in there is 4. Now what we said here is 4.23. That's what's in here. Here we assign that value, convert it to integer, store it in here. So why is it only showing 4? Well, because it's converted to integer, it takes everything at the decimal and kind of throws it away. So we're actually losing when we go from double to integer. The precision of the value is less precise as a result. So that's just something to keep in mind when you're converting from one type to another. In another video covering just converting from one type to another, we'll go more in depth with booleans and strings and how to convert them in an effective way, and what's the code that you use for converting from one type to the other.